presentation visible?
Yes. A very good morning to all the learners, and welcome my good friend Dr. Sukalyan Chakraborty in this session as an expert. I also thanks before starting a session for your continuous contributions since inception of this course and promoting sustainable science, involving from time to time as an expert, sharing your thoughts, your experience with all your learners. Today, dear friend, dear learners, I would like to take this opportunity to introduce my good friend, Dr. Sukalyan, to all of you. He himself now is associate professor at Civil and Environmental Engineering Department, Birla Institute of Technology, Mesra, and he has done his MSc PhD from University of Korea. He's a postdoctoral fellow at different universities like University of South Australia and the National Seng Kung University. Right, and he has a vast experience in different fields, and he has several awards and honors in his name, like he is the recipient of Fulbright Specialist Program grant from UCFE World Leading Center to host an American professor in India in 2019. He is a recipient of India Research Fellowship of Government of Australia. As you know, this is one of the very prestigious fellowship offered by Government of Australia. And then he is also Australia Award Ambassador, travel grant. He has received a number of travel grants from DST, Science and Engineering Research Board. So these are some of the his achievement, a number of publication from his team, research team of BITS at BITS Kelani, BITS Mesra. So with this brief introduction to all of you, I welcome you again, Dr. Sukalyan, and over to you to start.
Thank you. Thank you, Dr. Sharath. It is always a pleasure to get an invitation from Dr. Sharath and contribute in maybe a very limited way to this course. Dr. Sharath and many renowned professors with a dream have started this course. This course is running well. So my best wishes for this course and the whole team. And thank you for the introduction that you have given. So I think participants are quite less here. I think the recorded video will be sent to them. Okay.
Yeah. It will be in a YouTube channel or YouTube channel.
Okay. Right. So today I'll be talking on minerals. That is, basically I'll be focusing my presentation on mining of minerals, environmental impacts due to them, and what are the measures, what are the best practices that are done in these mineral industries, mining industries, to overcome the environmental impacts due to the mining process. Because when we talk about minerals, it's not only mining, along with mining, dressing, cleaning, processing, and finally transporting it and supplying it for consumption. So many things are actually involved in the whole process. So mostly I will be focusing on the mining sector. What are the impacts due to the mining of these minerals, and what are the things that are done to overcome these problems. Here's a definition of minerals. It's a naturally occurring solid chemical substance formed through geological processes. There are various geological processes which give rise to the formation of these minerals, like crystallization of magma, then weathering process, erosion process, chemical degradation process, even microbial degradation processes. Apart from that, metamorphism of existing rocks. So all these processes, many geological processes are there, which gives rise to minerals, mineral formations. So far, the International Mineralogical Association recognizes 5,762 official mineral species. And we know there are immense importance with regard to use of minerals. Like here you can just see a list of the sectors in which the minerals are utilized, like development of industrial plants, machinery, generation of energy, construction, defense, communication, medicinal. In one word, you can say from morning to night, all the things that we are using has got the contribution of some or the other mineral in it. Okay, so what happened? The demand of these minerals throughout the world has increased incessantly in the last few decades. If you see one just example of steel consumption here, if you refer to the graph, see the population is increasing in this way, and this is the graph showing the increase of the steel consumption. So what happened as we have uh, changed our lifestyles, we became greater consumers. So all forms of minerals we started consuming more and more. And one of the greatest demand of human civilization is energy. So energy requirement is every day increasing in leaps and bounds. And to fulfill that energy requirement, till now, most of the countries are relying on fossil fuels, coal, natural gas, crude oil, those things. This also comes under the category of minerals. Okay, so the demand for these minerals have increased in so manifold uh, ways to cope up with the energy requirement of the world. If you see any of the minerals from A to Z, you will see that there has been a huge demand of the minerals in the last few decades, and their demand, extraction, and supply has also increased manifold to cope up with this increasing demand. When the world population doubled between 1750 and 1900, mineral use increased 10 times. So population became double, while mineral use increased 10 times from 1750 to 1900. In the last 100 years, the mineral use has again increased 13 folds. So you can imagine here what has been the increase in mineral demand. Now, if you see the different types of minerals, I'll not go into much details about the physical and chemical physical and chemical nature of minerals and those things. Very plainly, I will talk about the broad classification of the types of minerals. Broadly, they can be of three types: metallic minerals, non-metallic minerals, and energy minerals. Now, metallic minerals, of course, you can understand that the metals, they are associated here. They are formed by reaction of various metals with other elements. They can be oxides or sulfides of the metals, carbonates, halides, which we also while others can be found in pure forms, such as gold. Metallic minerals are again further subdivided into ferrous minerals and non-ferrous minerals. So ferrous means which will respond to magnet, that is iron containing minerals, and non-ferrous are the other ones. Similarly, non-metallic minerals are also there, like silica, diamond, mica, coal, salt, potash, etc. These are non-metallic. They are not associated with any metals. If you see the periodic table, you'll find that metals, non-metals, and metalloids are there. So it's a clear demarcation which are the metallic minerals and which are the non-metallic minerals. And the third category is energy minerals. So those minerals.
There is a background noise. We are not able to listen properly.
Background noise.
Either somebody is to be muted. Not clear.
Is it from my end?
I don't know. It could be from one of the participants, and somebody needs to be muted through post.
Okay, Sharma, okay. Mute, I'm muting.
Okay. So the third category is energy minerals. So I told you that those minerals which are the supplier of energy, that means electricity is generated from them. They are known as fossil fuels like coal, petroleum, natural gas, etc. So broad classification of all the minerals can be done into these three categories. Here you can see the examples of metallic minerals, non-metallic minerals. Now we have precious minerals also. Precious minerals either can be of metallic minerals or they can be of non-metallic minerals also. Okay, like diamond is a non-metallic mineral. Similarly, several other precious minerals are there, and energy minerals, that is the crude oil, coal, and natural gas. These is just a tabular compilation of the different uses of minerals. Aluminium, we all know, due to its lightweight and very tough nature, it is used in automobiles, it is used in all types of automobiles, even aeroplanes and all are built from aluminium. Beryllium, it's used in nuclear industry and also in aircraft industry also. Barium, mainly barium radiography is done. Then barium is used in as a heavy additive in oil. Clays are used in.
I'm sorry, we're unable to hear this. Somebody talking at the background. I'm sorry, but it's disturbing. Can't hear.
डॉक्टर साहब आपकी नेक्स्ट कैबिन में they may be talking loudly. थोड़ा सा आप रिक्वेस्ट कर सकते. Otherwise, learners, please, increase your volume. You can manage. I am able to hear that. Increase your volume. Because he is taking from his department, that is the reason.
Yeah, and we have got cabins which are not exactly
totally,
they are not soundproof.
Yeah.
So that can be a problem.
Yeah. Anyway, so please increase your volume. I'm able to manage.
Requesting also doesn't seem good.
Yeah. That is.
So I would just request you to increase your volume.
Please continue.
Please continue.
Okay.
Please continue.
Okay. Sorry.
No, it is okay.
Inconvenience.
Oh, yeah.
So I was talking about the different uses of the minerals, some of the minerals, like fluoride. Fluoride, all of you know that it's one of the component which is used in toothpaste and all. Paints, they are used in carbon electrodes, etc. Pottery, ceramics. Copper, massive use of copper is there in this thing, in electrical cables and all these things. Iron ore forms the basis of the industry. If you talk about any industry, iron ore forms the basis of that. All the instruments are made up of iron or steel. So iron ore has got huge demand and huge consumption throughout the world. Silica is such a mineral which is a non-metallic mineral. It is used in refractory materials, constructing refractory materials. Then pharmaceuticals papers. You can go through this table. Many different uses are given over there. Phosphate, the main use is in fertilizers. We know that for phosphate and nitrates are the main nutrients which are required for the crop. So it's used as. Now coming to the extraction of the minerals. So this is the process. If you see how the minerals are taken out from the nature and processed and utilized. So if you follow this chart, the first step of that extraction of mineral is exploration. Now, we cannot go anywhere and start digging for minerals. So the first thing that needs to be done is we have to explore, and basically this is done by the geologists and geochemists. Okay, finding high quality ore. So different techniques are there, different mapping techniques are there, litholog study is done. So from that they come to know, then they study the outcrop, that means the type of the rocks present over there, the ages of the rock, and from that they finally come to a conclusion that this is a place where we can uh, find maybe this mineral, a particular mineral. So that's the exploration stage. Then comes the drilling and blasting. So once the exploration is over and we've come to know that, yeah, that mineral is present over there in that particular place. Again, the next thing is whether the mineral is present in the surface or at a certain depth. So that again gives leads to the planning that we should go for surface mining or subsurface mining. So after that, there is drilling and blasting. Drilling and blasting is done mainly to remove the unwanted materials, that is the overburden, which we call technically overburden, that is removed. And then we go for drilling and blasting and extracting out the precious metal. Now, once the metal is coming out, then it needs to be processed. The first process is crushing and milling, so that the size of the chunks which are extracted out of the nature, they can be minimized and they can be fit into the smelters and other processes where the ore smelting is done. So that is done by crushing and milling, getting the mineral out of the ore. After that is the separation stage. There are different techniques of separation. We will see a little bit of that one also. What are the different types of separation, like gravity separation, chemical separation, then flotation separation. We'll see that. Then it's the refining stage, cleaning the mineral or metal. And finally, it's the distribution. So this is you can see the chart which describes the process of extracting out the mineral from the nature and finally supplying it. Now, I was talking about drilling and blasting, that is the different types of mining. If it is found that the mineral is present near the surface, then we go for surface mining. Surface mining can be of open pit mining, or it can be dredging, or it can be also strip mining. So these three comes under surface mining. This one you can see here, it's an open pit mine. So minerals are extracted by removing the materials that covers the deposit. Open pits are formed on the mining sites. Okay, so of course, when we excavate out the material out of that area, then a pit is formed over there, a depression is formed over there, which is called pit in mines. Iron, limestone, copper, sandstone, and marbles are extracted by this type of mine. Another one is dredging. Okay, sand mining is the classic example of dredging. It is used for excavating harder materials such as gold and tin. Chained buckets, you can see here, the materials are all coming along this conveyor belt. Chained buckets and dredging lines, isko kehte hain dredging line. They are used to scrap out the minerals from underwater mineral deposits. They can be hydraulic or mechanical. So this is dredging. Third one is strip mining. Now here very sophisticated machines are used for strip mining, like bulldozers, power shovels, stripper wheels. What does that do? That just keeps on cutting the surface along a line. So that's called a strip mining. Okay, these are all types of open cast mines. And the second category is subs. Siddhartha sir, Ettu sir, Ettu aste sir. হ্যাঁ স্যার হ্যাঁ স্যার It involves usage of the vertical shafts, elevators. So these are the machineries which are used for subsurface mining. Underground mines जिसे हम कहते हैं. Okay, so now when the mining starts, there are various phases of mining. As I was saying, the first stage was exploration. Exploration is done by surface mapping, litholog study. What is a litholog? Like, say, when we find some indicators that a particular mineral can be found in a particular place, then we just uh, drill there and take out the cross-sectional soil sample. Okay, to a depth of around 20 meters, 30 meters, 60 meters. So when we take out that drilled cross-section of the soil, from that we can study the cross-section, study the litholog, and find out whether the minerals are found over. Uh, First thing is whether the minerals is present over there or not, and second thing is what is the quantity of the strata that mainly contains the minerals over there. What is the thickness of the deposit? Okay, so once I come to know that it is present, say near the surface and has got a good thickness, then only I go for the second stage, that is planning, mine site design and planning. After mine site design and planning, we go for development stage. So once the plan has been confirmed, the real work begins. And this is, of course, the operational stage of the mine, which takes the maximum time. So here we take out the overburden, dump it somewhere else. We take out the desired mineral, because mineral just does not exist like flakes. It is there attached to some rocks. So we take out the rocks from there, and we go for different processing of the rocks. The overburden is dumped somewhere else. So it's a lengthy stage. It's the most important stage, of course, of mining, and it's called the operational stage of mining. Ore extraction, crushing, grinding, concentrating. So all these things, waste rock, tailing management, wastewater management. Okay, so all these things comes in the this operational stage of the mining. Now the next one is production stage. Production stage also is very closely associated with the development stage or the operational stage, and then finally closure. So here mainly we will be talking about mine closure. So once I have taken out the required minerals from that place, then I need to go for mine closure. How is the mine closure done? Now, the main objective of mine closure is that you should uh, bring the land use pattern of that area to the original land use pattern, to the original land use pattern which was there before the mining started. Now, which is not possible always. Okay, because once we go for mining, mining is such a process that the whole land use and land cover pattern of that particular area changes. Now, bringing back that old land use and land cover pattern before it was mined is very difficult, uh, nearly impossible, you can say. So, what can be done? We can develop the mining area after the mining is over into such a sustainable manner, that means into such a what do I say, uh, sustainable land use pattern can be developed over there, so that the people who will be living over there can earn livelihood from there. And not only that, the environment of that area or the ecology of that area remains intact. So that's the mine closure plan, main objective of the mine closure plan. Site cleanup, reclamation, rehabilitation, maintenance and environmental monitoring. Maintenance and environmental monitoring for long run period, which is again a big challenge, because once the mining is over, it has to report to DGMS that mine closure has been followed and reclamation has been done. But in long run, the maintenance and the environmental monitoring of that place becomes a challenge. Okay, so now these are some of the processes of metallic and non-metallic minerals. Uh, Ore dressing. Ore dressing means, as I have told you, the mineral that I require, uh, it does not exist as flake. it exists combined with some rocks. Okay, now that needs to be removed. That means all the unwanted waste materials need to be removed. Those materials are called gang. So removing the gang parts of the extracted material that contain none of the targeted material or was too low in metal content to be worth smelting. So that means even if the metal content is there, but it's very low, then we cannot go for processing of that one. So that needs to be removed. So what is done for removing that? Mainly crushing and grinding. So grinding and crushing of ore is undertaken physically to liberate the valuable minerals prior to separation by physical and chemical processes. Okay, so crushing is done dry and grinding is done along with some wet chemicals like lime, soda ash, sodium cyanide, sulfur dioxide. These things are used for extracting out the minerals out of the ore. Okay. So grinding and crushing is done. Now comes the stage of ore separation. Ore separation, that means we want to take out the targeted mineral out of them. So whatever remains back, that can be classified into waste rock or tailings. The overburden that we take out first, that corresponds to the waste rock. Whereas the material which is actually shaded off by the process of crushing and grinding, that becomes the tailing. Okay, so a byproduct of ore separation is tailing, which is a mixture of water and finely ground rock, from which most of the minerals of value has been removed. I hope I can make this clear. That means the ore and the minerals are there in combined form. We need the minerals out. We need to discard the ores. For discarding it, we go for grinding and crushing process first. Then we'll go for other processes also. So during this grinding and crushing process, all the waste that is generated, that corresponds to the tailing. Now, there are two types of separation for this ore separation. One is physical separation, another is chemical separation. Physical separation is based on size, density of the materials that is to be handled. And chemical separation process that utilizes certain chemicals like we have seen cyanide, sulfuric acid, they are used for chemical separation. This is gravity separation. This comes under physical separation, gravity separation. See this one, the left hand side figure. So here there is water, okay, and the particles which are having higher density, higher specific gravity, they get collected at the bottom of this trough, okay, and the materials which are lighter, they get collected at the top portion of this trough. So what happens, depending on the mineral which I want to extract out, either it will get separated in the lower trough or in the upper trough. So whatever it is, I can separate it out from the tailings. So this process is gravity separation. Minerals separated on the basis of difference in density. This is done particularly for iron ore and gold as well as tungsten, tantalum and niobium. Another is magnetic separation. Minerals can be separated on the basis of difference in magnetic susceptibility. Say iron, if iron is there, iron will be attracted by the magnet. This is just referred to the right hand figure. This is the powdered ore coming and this is the magnetic roller. So what happens? The magnetic materials, they get attracted by the magnet. So they come and get collected over here. Whereas the other particles, non-magnetic particles, they get collected in the other container. So this is another method of ore separation. Third one is flotation separation, which I was saying. Flotation separation is very common. and it is used in most of the industries. So it depends on the nature of the mineral, whether it is hydrophobic or hydrophilic. Now, what is done in this? The minerals are all sprayed over here along with the ore, and air bubbles are pushed into the container from below surface. Okay, an agitator is there which drives all the air bubbles towards the top of the container. Now what happens? If the minerals are hydrophilic in nature, then they will not go and adhere with the air bubbles. But if they are hydrophobic in nature, they will go and adhere with the air bubbles. Here you can see they are adhering with the air bubbles. Now what happens? All those hydrophobic minerals which are adhering to the air bubbles, they will go to the top of the container and get collected over there. Whereas the hydrophilic materials, they will remain at the bottom. And now, depending on the nature of the minerals, okay, my targeted mineral, whether it is hydrophilic or hydrophobic, I can separate it out. Either I can separate it out from the top, that is the froth containing the hydrophobic material, or I can separate it out as the tails, which is containing the hydrophilic material. So this process is called flotation separation. Next is chemical separation. Chemical separation is also very efficient, uh, better efficient than the physical separation processes. But main thing is it leads to a lot of chemical pollution, discharge, waste discharge, acid discharge. Okay, chemical separation is done with, say, leaching with cyanide. Okay, a dilute solution of calcium or sodium cyanide is given, and what does it do? Say pH and temperature is controlled, and there is agitation of the material along with the sodium cyanide or calcium cyanide solution. So what happens? The ores and the minerals get separated out. Now the minerals are absorbed by activated carbon granules. Activated carbon granules are already there. So these activated carbon granules, they catch hold of the minerals and they separate it out. This is called the pregnant leach. Okay. The next one is same thing, but here leaching with sulfuric acid. It depends on what mineral we are going to leach. Leaching with sulfuric acid is done for uranium ores, and here the capturing material is resin or organic solvent. So what happens? The uranium comes out from the ore and it gets captured by the resin or the organic solvent. So this is a leaching process, and this is called the chemical separation process. It depends on what mineral I want to leach. So I select it for a cyanide leaching or for a sulfuric acid leaching. Okay, so far it was all about uh, different types of minerals, their processes. Unless we know the process, we cannot come to know about the impacts, environmental impacts. Now, these are the impacts of mining. Air pollution and suspended particulate matter. A lot of dust is generated over there. Okay, surface and groundwater pollution. If there is chemical separation process, or not only that, whenever mining is done in any area, what happens? It leads to unconsolidation of rocks. Now, whenever the rocks become unconsolidated, what happens? The acids and the other solvents, they just penetrate into the layers of the rocks. And there, they react with the ores and minerals uh, and can leach out much of the heavy metals which are present in the soil and rocks into the groundwater, or if they are collected in the mine pit as surface water. So that is again another problem. Sound pollution for the blasting activities, drilling activities. Agriculture, forest degradation, of course, this is the first thing that is done when we go for mining. Soil erosion, topsoil degradation. I'll say something about the topsoil also. Topsoil management, how is it done? Socio-cultural problems, that is rehabilitation of the people from the site of mining to somewhere else, and land or mine spoil. These are the examples of some of the air pollution from mining. Air pollution due to ground activities, that is uh, direct mining activities, haul roads, conveyor belts, then blasting, drilling, and this one is smelting. So these are all. Now, water pollution is also very high in case of mining activities, specifically for the metallic minerals, because acid mine drainage. Not only that, even for the energy minerals, if I talk about coal mines, the coal which contain high amount of sulfur in it, it leads to formation of acid, and correspondingly it leads to acid mine drainage problems. So acid formation is another problem, and these goes either to the collected surface water or into the groundwater. It infiltrates and reaches the groundwater. Soil erosion, deforestation, and migration due to mining. So, real problems. Other problems, sometimes it happens that other problems can be tackled, but the migration due to mining and rehabilitation of the people, it becomes a big issue. Now, here is a comparative picture. Alteration of land use. So this was before mining, the upper one, and the lower figure, both are aerial photographs, and the lower one is after mining. Here you can see the mine pit, all the collected water there. This water is normally very high in heavy metal concentration, because all over the mining, this becomes the catchment area of the precipitation is which is happening all over the mine. So surface runoff, surface erosion from all the parts of the mining areas, they come and get collected over there. And normally this is having high metal concentration. So what happens, this water cannot be used for drinking or such purposes. And when it stays there for a long time, it keeps on percolating inside. And once it starts percolating, it goes to the groundwater, contaminates it. Okay, so basically categories of mine waste, when you talk about the categories of mine waste, it is overburden, like the upper material, unwanted material, waste rock, similar like overburden only, tailings, that is a residual slurry of ground up ore that remains after minerals have been extracted out, and heap leach spent ore. That means, as we have seen here, chemical processes, so we get a residue there. This residue is actually the heap leach spent ore. So these are the problems of mineral mines. Tailing management, how is it done? Tailings are usually discharged into storage facilities retained by dams, okay, or embankments. It has to be made sure that it does not leach out. Neither it leach out horizontally, nor it leach out vertically, percolates vertically. So it is confined within some embankments or dams created over there. When tailings are discharged into the facility, solid fraction settles down, forming a bitch, enabling the slurry water to be decanted and discharged or recycled. So when it is retained for some time, there is some degree of settlement of the tailing materials, solid materials, which settle down, and the water can be reused. Tailing storage facilities usually contain residual chemical and elevated levels of metals. It is vital to ensure their chemical and physical stability. Okay, as I've told you, that it can leach in any of the directions. So PVC flooring is given over there. Plastic coating is also given sometimes so that there is no leaching. Conventional actually when this slurry, the whole thing, the tailing slurry is retained for some time in a tailing pond, uh, what happens? The water separates out, and the tailings which settle at the bottom, that become thickened. Okay, So that thickened sludge can be taken out and utilized for other purposes, depending on the chemical composition of that. So that is how tailing is managed. Sometimes the co-disposal of tailings and waste rock is done. So what happens? There are gaps in between the waste rocks. Okay, so the liquid of the tailings, they just penetrate through the waste rock, and after some time they get stabilized over there. So this is a practice which is done in some of the mines, co-disposal of tailings and waste rock. Okay. Uh, so what happens? The land requirement becomes less, the percolation chances become less, and both the problems are tackled at the same time. That is of tailings and waste rock. Acid drainage, as I have told you, mainly chemical leaching processes where they are happening, they lead to acid formation. Okay, basically it happens in circumneutral pH range and in presence of water and oxygen. It's an oxidation reaction. So other factors like presence of the sulfide minerals, temperature, acidity, and also the action of certain microorganisms. Basically, the most important being thiobacillus pyroxicans. एक microbe होता है which mainly converts the sulfide into sulfate, leading to formation of sulfuric acid. So acid drainage, which is acid which is formed in some of these mines, that is a big problem, because acid, when it goes and reacts with other ores, it dissociates the metals out of that, and the metals now come into the water, groundwater as well as the surface water. Treatment of acid is done in two ways. One is the conventional way, that is to dilute the acid by treating with water, adding water. And the other one, which is a very innovative way of treatment of acid mine drain, is constructed wetland. Constructed wetland actually comprises of many biological organisms. Wetland plants are there who have an extensive root system. Algae is there, as well as other bacteria and fungus are also there in a constructed wetland, along with the base material formed by gravels, sand, and soil. Soil means clay. Okay. So what happens? One is physical separation, physical filtration due to the layers of the soil over there in a constructed wetland. Second one is these plants, which are mainly hyperaccumulated species, they can take up the metals from the water. That is the effluent, the discharge. The algae, they can also uptake metals. Okay, and the bacteria, they can lead to reverse oxidation. Okay, again forming sulfate into sulfide. So overall, it's a very synchronized process, that is a constructed wetland, which helps in absorbing, adsorbing, filtering, and precipitating the acid and other impurities in the discharge. So constructed wetland is the best way of treatment of acid mine drainage. Now let us come to the reclamation of mined out areas and overburdened dumps. So the overburden that we have taken out from the mines, so the overburden which is taken out from the mines, that is unwanted materials, one is concurrent backfilling. Concurrent backfilling means the place which you are digging today, the next day you go to a second place, you advance, that means. Okay, so when you advance, say you digging in this spot today. Okay, you dig out the material, the overburden, you dump it somewhere, and the precious metals or the targeted metals you take away for processing. The next day, what happens? You advance. So next day, you go for mining of this place. This is your first spot. This is your second spot. Again, you take out the overburden and you go for dumping, right? So the second day, when you go for dumping these overburden, it is expected that already the mining of this place is over. So you fill it up, and this process is called backfilling, and go for reclamation of that area. So what happens when you advance in a mining area for some time and you come to the extreme end of it, already you have reclaimed the area till your last site. Okay, so backfilling vis-a-vis reclamation, these has to be concurrently done when we go for mine closure plans. Now, how is this backfilling and reclamation done? Basically, it consists of four methods, four steps. Number one is technical reclamation, because lot of erosion happens in this overburden dumps. Today also in the newspaper I have read overburden dump in Dhanbad led to death of 4 persons. Okay, so maintaining the slope stability of these overburden dumps, and also um, to make them environmentally safe, it is a big challenge. Okay, so erosion happens at a very accelerated pace in these overburden dumps. So this needs to be checked. For that, we go for different types of technical reclamation. I'll show you what are the different types of technical reclamation done. Apart from that, biological reclamation, topsoil management comes under technical reclamation. Biological reclamation, that is first making the soil fertile and then going for stabilization of the soil, followed by plantation. That means greenery development, vegetation cover development, and the last one is aftercare and maintenance of the reclaimed site. So these are the steps which are mainly taken for reclamation of the mined out areas. So topsoil management. Now, what happens? I was telling you about excavation of one area. Say I'm excavating this area, right? The soil which is present here, this is the topsoil. This is the topsoil. Below that we have the subsoil, and then we have the consolidated bedrock. Okay. Now my deposits of minerals, that happens in this subsoil. So what happens? This topsoil and part of the subsoil till I reach the strata, I take out as overburden, OP, overburden. And what do I do? The topsoil I take out and dump it here. Okay. Then I take out the next layer and I dump it at the top of this. I take the next layer and dump at the top of this. So what happens? Slowly, the overburden which I have been creating, the topsoil, that gets collected in this place, that is the center of the heap, and the subsoil on top of that, these are the layers of the topsoil. So what happens? Slowly, the outer layer remains aerobic in nature, whereas the inner layer, it becomes anaerobic. So the microorganisms who are mainly present in the topsoil, who leads to increase in fertility of the soil by nitrogen fixation, nitrification, phosphate solubilization, all these phenomenon, all these processes, what happens? The fertility of the soil increases. But here, all those microbes which are present here, who are responsible for increasing the fertility of the soil, they die out due to the creation of anaerobic zone in this region. Okay, so after this one is done, say when we go for backfilling, what do? Again, we take out the subsoil, then we take out the topsoil and dump on this. So now when I bring back the topsoil, it is totally unproductive soil because all the microbes which were present there, they have died. So this requires some attention. What is done in some very specialized reclamation processes, this topsoil is dumped somewhere else. Topsoil is dumped somewhere else with smaller heaps, and regular mulching is done there so that the microbes remain intact, and the rest of the soil is dumped somewhere else. So when I go for backfilling, I take this soil first, and then finally I bring this productive topsoil and dump it at the top of this. So this is called topsoil dump management, so that the microbes remain intact in the topsoil, and also it leads to good fertility of the soil. This is how the topsoil is sprayed. See, this is transforming the OB dump ready for bioengineering measures. This is the OB dump. OB dump is first levelized, and then the topsoil is sprayed on this. Here you can see in progress. And finally, when we get the topsoil cover done, then this is ready for bioengineering. Dump configuration. Now this needs to be followed when we go for slope stabilization of the overburden dumps. Two things need to be followed. Slope angle should be less than 28 degrees, and there should be back slope. Why is the back slope required? So that the materials which are getting eroded and coming to this step, if this was not a back slope, if it was something like this, then what would have happened? This would have continued down. But to check this, what is done? To check this, back slope is done in between. Okay, to check this, back slope is done. And here you have a garland drain. At each layer there is a garland drain. So all the water which flows through this garland drain, they come to a common discharge point. This is the dump configuration which is to be maintained while we are going for dumping the overburden. And slope angle should not be less than 28 degrees. That would invite problems. This is terracing, how the slope is maintained. Contour trenches to check erosion. Contour trenches like step cuts are there, so that when there is erosion also, it gets stopped in the next layer. It does not come at the foothill of the dump. These are again some of the features like cribs and gabions to check soil erosion. These are like small check dams, cribs, so that eroded material, they get stopped here in the barriers and water just flows. Gabions are certain depressions created. Okay, so whenever minerals will, so whenever this waste rock and the dumps will get eroded, they will come and get collected over here. The water will flow, but materials will get captured, settled in this depression. Okay. This is a garland drain, which I was saying. Every layer has a garland drain like this. Acha, garland drain to again stop the water from the garland drain to overflow. This is a toe wall which is created along the garland drain. Toe wall like this. An elevated wall like an embankment, similar to an embankment. Toe wall. See, this is a toe wall, so that water does not overflow. Okay, and towel has got a special feature, yeah, which is called weep holes. That means water, you cannot stop water like that. No, the water will come through this. There are pore spaces. Water will come through this, but the sediment will stop over there. So that's a towel. Now, after doing all these things to check the soil erosion in a mine dump, next we have to go for bioreclamation, that is planting of trees. Before going for planting of trees, we need to check the parameters of the soil. Like we need to check the soil pH, which is 6 to 7.5 is ideal. We need to check the soil fertility, that is organic carbon content, nitrogen, phosphorus content, potassium content, even some minor nutrients like iron, manganese, copper, zinc, rock content, because most of this overburden, they contain a lot of waste rocks. Okay, so soil should not have a stone content greater than 50%. Then we have to mix more soil into it if we want to go for plantation. Soil texture is seen, soil aggregation is seen. Soil aggregation mainly happens due to calcium, magnesium, sodium, potassium ions in the soil. If they are not in balanced quantity, they lead to aggregation of soil. Then moisture bulk density. Moisture bulk density is seen so that to ensure that the soil will be able to hold moisture or not. Okay, so these are the parameters which are seen before going for plantation. Now, when all the things are seen and we are ready for going for plantation, the first thing that we need to do is to stabilize the soil first, because next time when there will be precipitation, rainfall, the whole thing will wash out. So for that, I go for geotextile application, something like this. It is pinned on the surface. Here you can see it's square, it's pinned on the surface. Okay, and plants, seeds are just thrown on top of that. So it leads to germination of seed, vegetation develop over there, and the soil becomes stabilized. Mainly, which type of seeds do we go for? Those plants whose root system is quite extensive, so that it can hold the soil firmly. Then we go for no. Before going for plant species, further higher plant species, we even go for sometimes spreading microbial seeds over there. Microbial seeds means microbial cultures. Microbial cultures of nitrogen fixing bacteria, nitrifying bacteria, denitrifying, not denitrifying, nitrifying bacteria, phosphate solubilizing bacteria, so that when they colonize in the soil, the fertility of the soil automatically increases. Then finally, we go for vegetation development. Now, these are the things which need to be taken care of when we go for vegetation development. One is timing of revegetation. What is the time when we will go for plantation? Second is species selection, which is again based on a number of factors like this. Whether the plants can grow in that geoclimatic area, उसके economic importance है कि नहीं, aesthetics is one of the factor, whether it's ecologically sound or not. We cannot go for plantation of eucalyptus trees because they are water guzzling plant. So we need to assure that the plantation we are doing, it will be ecologically sound over there. It will lead to development of an ecosystem. जो ecological succession process है, that will be formed over there. Similarity with surrounding vegetation, faster growth species, nitrogen fixing, easy to establish, improve fertility of the soil. So these are the conditions taken care of when we select the species. Then it is identification of seed source, nursery development, plantation, and provision of water facilities. These are done for developing greenery, that is vegetation in a overburdened dump. So these are some of the measures which are done for mine reclamation and treatment of mineral processing, ore processing, and those processes. Okay, so now if you have any questions, please.
Yeah, now the session is open for discussion, and I request all the learners to show their camera on. Keep keep your camera on, please. Please come on the camera so that we can have photo session. Dr. Saab, please, okay, please do that. Sharing बंद कर दीजिएगा.
Stop share.
Stop
Okay,
sharing.
yeah.
We can have a common
Hmm.
so that. So others also please put on your camera. Parul, Bijumon, Naresh, Dulita, KK Sharmaji, Sanjeevani, Abhi Pawar, Deepak, Vikrama, Brijesh, Arun Sharma, please. Yeah. Okay, thank you. Now session is open for